Welcome, everyone. My name is Jason Clark. I work for New Relic, specifically on the Ruby agent. So that's the New Relic RPM gem that maybe a few of you are familiar with and have installed once or twice. And I'm here today to talk to you about ways that you can make your gems more extensible, more flexible, and talk about a lot of the pitfalls that you might run into in building a gem that other people might want to build on top of. But before we get too far into that, I want to start with a little story time. So New Relic does performance monitoring for your Rails and other applications. One of the things that we do is we will inject a little piece of JavaScript into the footer of your page so that it can get timings on the client side and then transmit those back to us so we can paint you pretty graphs and show you alerts for what's going on. So in the Ruby agent is the piece that you put in your app. There's this little piece of code, and here's a snippet of it where we're figuring out the queuing time, and then we've got all this ugly business that we were doing around rounding and clamping and making sure that things are fine. And then we emit this footer, and that actually ends up in your page. Well, this is the type of code that, when you're making another change in an area, you might want to refactor a little bit. And so we extracted a bunch of the timings out. We moved a bunch of that logic around, what's in milliseconds, what do we round, what do we do there, into a transaction timings object, which cleaned this interface up very nicely. This, is kind of deep in the guts of the agent. It's deep in our code, and so we felt pretty good about doing that and then removing that other browser timing method that was there. Unfortunately, there was a problem. Elsewhere at New Relic, we run a Rails-based application, our website that you might go and log into. And this method happened to show up in there. So we were monkey patching the footer.js string so that we could modify that and put it in there. And we use our own site to run our software and experiment with things. But we didn't catch this until it got onto dev. It didn't make it to production. Nothing broke. But this is an example of the sort of problem that you can have when you tromp on something in another gem. The Ruby agent didn't provide a good API for somebody else to extend it the way that we would like them to. And so to get their work done, they did the only thing that was available to them, and it caused both of us pain in the end. That's the sort of situation that I'm here to talk to you about today and give you a lot of tips all the way from small things that you can do all the way up to how you pattern your applications and gems so that you can avoid the sort of pain that happens when people plug into your gems in ways that you're not expecting. Maybe you want to write the next big application server. You want to get in the fray with Unicorn and Puma and fight it out. Maybe you think that you've got a better idea about how to do background job processing. All these other frameworks have got it wrong. You've got the plan. Or maybe you've just got some little utility gem that you want to put out there and have people be able to use, and you want people to be able to build on top of it. Whatever the case is, there are ways that you can make your life easier and make the life of your gem users easier as well. So we're going to cover a lot of material, a lot of little cases that we've run into at New Relic. So we're on both sides of this. We hook into other gems to be able to monitor and get timings for them. And other people build on top of us and put us in their app. And so some of these examples will be things that we've run into with other gems and worked through with them. Others will be things that we've screwed up and made other people's lives hard. And we'll hopefully learn a lot from all of those. We'll talk about how you can pass things into your gem and patterns for doing that to make it easy for people to modify the behavior of your gem. We'll talk about using events to make things more decoupled, giving a good interface for people to hook in to your gem. We'll talk about the middleware pattern, which is a very powerful way for letting people interject into kind of a request lifecycle within the life of your gem. We'll talk about lifecycle for broader things, more application lifecycle for web servers and background job processors and making the changes you need there for people to work. We'll talk about naming, configuration, documentation, all of the sort of peripheral things around your gem that surprisingly can make things a lot easier or a lot harder depending on how you do it. So let's move on to the first topic, passing things in. A great case for letting somebody pass something in, the simplest sort of way that you can let somebody modify the behavior of your gem is to let them hand you an object. And a logger is a really great example of that, and one that you probably should be doing if you're doing some sort of logging from your gem. We have here the one positive case that I'll take out of Active Record today to show you of a pattern from a gem. It actually happens to be the only thing that I'm taking out of Active Record in this case. But they will let you set the logger. It's right there on the base. You can hand it an object, and that's what it'll use to log. If they didn't do that and you wanted to change the output that they do, where that goes to, pipe it somewhere else, put it to a file, modify it in some way, you would be forced to grovel around in their internals or find where they're doing that logging and monkey patch it in some way. So letting them surface that logger, just give access to that object on the top level, gives you a lot of flexibility. In other circles, this is commonly known as dependency injection, but if you're like me, that makes you think of something in Java with factory managers and a bunch of XML to wire it up. It doesn't have to be, though. Dependency injection just means that you let somebody else provide you with the dependency that you need to work with. And in this case, with the logger, it's just a matter of a single accessor for the object that you're going to use. This is a lot simpler in Ruby than it is in some other languages as well because of duck typing, although that's kind of a double-edged sword. In the case of the logger, you need to make sure that your logger supports all of the same methods that would commonly be exposed off of the logger class that Active Record is expecting. It's highly recommended, from what I've found, to provide some sort of spec if you're intending people to pass an object in for this type of case. Maybe not for a logger because that's pretty common and people know, but if you've got anything more specialized, you want to clearly communicate what that contract is that other people are going to be building their code against. Another great case for doing this sort of injection is instrumenters. And this is obviously very near and dear to my heart, being at New Relic. And I love to see gems that provide ways to let you wrap around and measure the timings for critical things that happen within them. A good example of where this had been done was in the XCon gem. So XCon is a HTTP client library. And when you spin up the new connection, it gives you this instrumenter in the hash that you can provide. And you give it a class or a module, and it will go, and it will use that to wrap around all of the HTTP calls that it makes. This is a really nice idea, and it lets you build a simple little instrumenter class that just, does whatever timing or output or logging that you want to do, and then you yield, and it carries on with its business inside of there. Unfortunately, there's a little bit of a problem with this, and that's the fact that there is one instrumenter allowed in XCon. So on the surface, this looked like exactly what we wanted when we came around to instrument this particular HTTP library, but in fact, we couldn't use it because it would tromp on somebody else's instrumenter that they might have set. The application that was using it might have already set one, some other library might have, or XCon itself might set something there by default. All of those cases wouldn't have allowed us to easily pass that in and modify it without risking ruining somebody else's behavior. This is a theme that we'll come back to a number of times throughout this talk, that if there is a place where you have a single thing, whether it is a hook or an object that's being relied on, that potentially locks people in how they interact with your gem and makes it difficult for people that want to extend it to do the things that they need to do. Another great case for passing things in and allowing different functionality is backends. So assuming everybody else uses the same data access library or gets things together in the same way as you do is kind of confining. A good case for this was the delayed job gem. So delayed job is a background job processor. The first line is a demonstration of just a piece of Ruby code that you would do. And with delayed job, you can say .delay, and then call the method that you would. And what that delay actually does is serializes enough information into some data store that it can run that piece of code for you later. And in the early versions of it, it was tied to Active Record, but then they broke this out into separate backends that you could provide. And I think there was a data mapper implementation and a Mongo implementation. So they actually went so far as to make it so that you could provide separate backends as gems that would hook into this. And that's a really nice structure for being able to do that. There was a little bit of a weirdness, though, in how the interaction went with these back-end gems, and it caused us some issues in the instrumentation that we wrote for it. And it specifically was this line. So what that does, you provide it with your back-end, you've got your own class in your gem, but then they were coercing that to be the delayed job constant. So when we came to this library, we thought, oh, the delayed job class, that's the one that we ought to instrument things around. And we wrote some code that looked a little like this. So we looked for the count on it. Well, this seemed safe. We're talking to something that was right there in delayed job, right? Well, no. We were actually talking to something that was a separate plugin that wasn't part of the main API, and if you tried to use delayed job with something else, it would fail. This isn't something that you can even cleanly protect against in a lot of senses, because just looking for a respond to on count doesn't necessarily imply that it's going to work properly when you call it with these methods. So it would have probably been cleaner if they had left things not making it look like that back end is something that's in the base gem, but maybe provided a different way that you could access and check it to figure out what capabilities it had. There are a lot of ways that you can make specific things to the functionality of your gem in the objects that people pass in. So the example that I have here is rescue. So rescue is another background job processor. You provided a job class with a perform method, and it allows you to enqueue that job, and then it will write that to a Redis backend, and a separate process will then consume that and run it later on. So the way that they let you customize this is they provide before and after hooks for a lot of different pieces of the life cycle of your job. So they have a way that if you name a method with before perform on the class that you're handing in, then it will go and find all of those and it'll run them for you. So in this way, they give you a very tidy interface for modifying your job class in the way that you pass it in to get the work done that you need to do around your job. And as an instrumenter, as somebody that works on top of Rescue at New Relic, we use exactly this functionality to be able to wrap around your perform on a job and take the timings that we want to get to figure out how your jobs are doing. Another key point about this is that this is also documented. They have a nice page that spells out all the hooks and what they are. Because this naming with before perform and then you can name it whatever you want after that is very flexible. Without the documentation, it may not be clear without reading the code exactly what's going to be supported and what's not. But they make that very clear in the docs, and that's a plus and something that we'll touch on later, too. So there's a lot of different ways that Ruby, being very object-oriented and duck-typed, allows you to let people pass different things in than what your base implementation is. So when you're writing a gem, think about the ways that people might be able to simply pass things through to get different behavior than what they might be getting out of the box. There's another way that you can let people intercept and find out about the things that are happening in your gem, and that's events. So when I say events, there's probably a lot of things that you might be thinking. Maybe you're thinking, node and asynchrony, or IO-driven stuff, or maybe if you've had bad experiences like me, you're thinking Visual Basic event handlers. Anybody? No? Okay, don't think about that too hard. When I say events, what I really just mean is ways of notifying external code that important things have happened in your gem, giving them points where they can hook behavior onto what you're doing. I've actually given a whole talk about this, and an eventing system doesn't have to be complicated. I've written up a little gem, not necessarily for production usage, but to demonstrate it's maybe like 50 lines to write this sort of event system where you can notify of something that happened and have an arbitrary list of subscribers that are interested run their code when the things that you care about happen. This provides a really nice interface just because it separates the classes. They don't have to know about each other. They talk to each other through that event interface. And that's a really powerful thing that you can do when you don't control the code on both sides. How you surface those events is kind of up to you, but it makes a lot of sense to kind of front load this into a place that's very visible and very easy for instrumenters and other people to access. So in the New Relic Ruby agent, we've actually started using this. And so on our agent, there is an events object. That is the primary event listener that is in our system. And then here's an example of how you would subscribe to that. So this says, hey, when I start a transaction, I've got some custom parameters work that I want to do. That block gets executed whenever we fire start transaction. You have to know about the agent and the events object node to get to that, but then you don't have to know anything else about our transaction class. You don't know any of those details. You can just wire this block up. Rescue has a similar sort of hooking mechanism, although they do it directly off of the top-level modules. So you can set this after fork hook. So when Rescue runs for each job, it will fork off a new copy of child process, and each of those will run this after fork for you. This actually turns out to be pretty important because this line is very commonly added in cases where people are using Rescue or other forking frameworks to make sure that your database connections are all there in the child. You can run into problems if you don't reestablish those connections. This turned out to be an issue for us at New Relic, though, because we actually have some work that we really want to do in the after fork from Rescue as well. We use some background threads. We'll talk a little more about that later. But we needed to have an after fork, and as it turned out, there was only one of them. In some earlier versions of Rescue, you got one after fork hook. And so either we didn't get our thread started because somebody else came along later and registered their own after fork, or we tromped over somebody else's after fork hook, and then their database connections might not work, or whatever functionality they were rewiring at that point would end up broken. This was not a good situation at all, and we ended up having to, when people would run into it, they would have to make their own after fork that did both the database stuff and called over to our piece of code and did whatever else they needed to have happen there. Not a good situation for anyone. So the fix for this turned out to be pretty simple, and they put it into Rescue 2 or 3 versions back, and that was simply to make it so that after fork had an array. It held on to multiple handlers and allowed you to put those in there. And so it was wonderful that the way that they did that was actually API compatible. Nobody had to change their code necessarily to make that work correctly. And if it had been that way from the start, it would have been nice, but where we're at today, you don't have to do the sort of custom hookup that you do. So if you've got, again, one thing, think about whether it might make sense for there to be more than one. Make sure that you're not going to be running into a situation where different people are going to tromp on that single object and run into problems because of it. Working with events, one consideration is whether there is order dependencies in the event handlers and the things that need to happen. And it's kind of a pressure against using an evented sort of mechanism for this because they don't really support events. I don't know what order the things that I put in to start transaction are necessarily going to get called in. If it matters a lot, you might want to think about doing things differently. But that's kind of a thing that might push us to some other techniques that we'll look at a little later. Also want to make a call out as well that Rails in active support, since about the 3.0 version, has shipped with a thing called active support notifications. And this is basically a built-in event notification system like what I described. The interface is very similar to what we've shown that we use in the agent, although we've got our own little implementation since we can't depend on a specific version of active support. So a lot of things in Rails are already using this. This is how a lot of the logging happens. A lot of things that underpin Rails are already built on top of this. And so depending on the context of your gem, you might consider wiring into that. I've seen a lot of things as well where people are optionally wiring into it if they find that it's around and firing off interesting events that people might want to subscribe to. Which is kind of nice to provide that visibility if it's there. So events are a really powerful way that you can let people hook into your code in a decoupled way and respond to the important things that happen during the lifetime of your gem. But another way that you can handle things, especially if there is order at play, is the pattern of middleware. So most people are probably familiar with middleware primarily from Rack. So Rack is a very common library that's used under the vast majority of the web frameworks that we're familiar with today in Ruby, Sinatra, Rails uses it. And basically, the metaphor that it has is that there is a stack of these middlewares. And when a request comes in, it gets handed through each of these layers in this middleware stack. Each of them have the opportunity to do something in response to that request, modify the request. Eventually, it gets to your application, you generate content to send back out, and then that response percolates back out through that middleware stack, and everybody, again, has an opportunity to look at that and do what they need to in response to it. So the interface for this is really slim. You just define a call method. It takes an environment, which is a hash that has the values from the request and the values from the environment, the server environment and things that come through, and you're responsible to make this app call and pass on to the next layer of the stack. It's really very slim and very nice in that way. The environment, though, can be a problem in this sort of setup. It's very wide open. This hash is just there, and any of the middlewares that are in that stack have the opportunity to interact with that, sometimes in ways that you might not expect. This is just the list of the base things that I saw in a Rails application that I had there. And it's pretty easy for there to be leftovers. It's pretty easy for there to be things that happen in that environment that you might not be expecting. Especially if you do things where maybe you mount a Sinatra app inside of a Rails app and string these things together. I've definitely seen cases where there are things that are left in the environment from prior layers of the middleware that cause behavior that you're not expecting. So it's just something to be aware of. You know, if everybody's tidy and clean and writes their code well, this doesn't end up being a big problem. But it can happen when you're passing off through so many different layers. There's also a problem with introspection in the way that Rack has implemented the middlewares. Rails and Sinatra actually wrap some things around this so you can see what that stack is. But at the base of it, all that Rack requires is that each layer knows to communicate to the next one. Like that app instance variable is the connection between those. And there's no reason it has to be named app. I could store that wherever I want to. And so if you're wanting to look at that stack, look at what's in those Rack layers, you kind of are in for a little bit of a hard time if you can't assume some version of Rails or Sinatra that's there to help you. Middleware is not necessarily restricted to just Rack and the web, though. I've seen it applied very well from the background job processing framework Sidekick. So Sidekick, unlike Rescue, which forks, Sidekick uses multiple threads to do that processing. And there are actually middlewares that are provided both on the side of adding a job into the queue and taking the job off of the queue and processing it on the server side. And so a middleware in Sidekick looks like we see here, very similar to what we had in Rack. Tells you the worker, tells you the message, gives you some information that you can set up. This is really nice because it gives you a very structured way to organize those pieces. And in addition, there is a directly exposed way to see what that stack of middlewares are. You can add them very simply in this way, but you can interact and you can look at that list. And so as a third party, being able to potentially look at what's there, make sure that you're not already added, potentially sense other things that are going on in that middleware stack is a really big plus. So that's the middleware pattern. It's a good way to deal with things when you've got events that might need to be wrapped around what's going on in your gem, but you care about the order and you care about the sequence that they happen in. So sometimes you write gems, sometimes you might be writing something where there's kind of more of an executable aspect to it, whether it's a web server or some sort of service that sits there and monitors something, background job processor. A lot of times, those sorts of applications will run into issues around forking and demonization. So at base, what happens with forking is that you're running a process and you make a call to process fork or one of the similar overrides of that exist. And the underlying operating system will make you a new child process with its own identity, but with an exact copy of the state of the process that you started in. And in that child and parent, then execution continues from that point in code where fork was called. So it's really nice if you're writing an application that does this sort of forking to provide hooks for before and after the fork. This lets people that might be interested in making the state of the world be a little different than it was take care of their business either before you go off and take care of the fork or after it. One really concrete example of why you might want to do that is the fact that I just kind of lied to you. When I said that the state of the child application is exactly the same, there are some things that don't carry over. When you have multiple threads executing in a process, only the thread that called fork ends up in the child. Now, maybe you're thinking, okay, well, so those threads go away. Why do we care? Well, for example, New Relic runs a background thread that will send the data for your performance monitoring once a minute. If we start up in the parent process and then you fork, we don't have our background thread to report that data back, and you don't get your graphs. So for us, it's critical that we know when we've forked so that we can restart that background thread in the child process. But without hooks, there aren't hooks built into the Ruby language to get at this in a generic way. So without you as a gem author providing those spots where we can hook into it, we're kind of in for a bad time. There's also some other issues that we've run into around this, specifically related to locking and multi-threaded concurrency. So if you have a lock held on a background thread, and then the fork happens on another thread while that background lock is taken, the lock state carries over to the child, but the thread that actually owned it isn't there to let it go away. Now, some of this might be bugs at the Ruby VM level. We've actually seen a few patches come through to deal with some of these, but you got to be aware that threads and forking, you probably are in for a little bit of a bad time. Actually had a long thread on this on the rescue project, talking through some options, and it's amazing the lengths to which some people have gone to get this stuff to work correctly. There have been patches to Ruby, a lot of stuff around exact versions of the operating systems that you work with to take care of that. If you're running an application that's also responsible for loading gems, there's a lot for you to consider around how you interact with things to give third parties the hooks that they need. Unicorn is a great example of this. It's a forking web server. Master process starts up, spins off worker, children that actually handle the requests. And they have a couple of different modes that you can run in. You can either load the gems in the parent, or you can load them later on after things have started in the child. The unfortunate part about this for us is that because things get loaded late in the life cycle, if you set the preload app to false, we actually can't instrument the right things when this goes on. Because we don't get the hook after the load has happened, we want to actually instrument something that has already been called in Unicorn. And so we can't get the cycle of that correct. It's a difficult thing to work through, but if you're loading gems, it's good to pay attention to when you provide hooks and what the life cycle is that people might need. So that's the life cycle of a broader application, gems, a lot around forking and threads, a lot to look into and a lot to think about if you're going to write something that works that way. Moving on. So naming is a hard thing, right? It's one of the two hard problems in computer science, the other ones being cache invalidation and off by one errors. So it's something you definitely got to pay attention to. There is a thing in the Ruby community which has been very great for Rails called convention over configuration, right? And another way to think about that is it kind of forces you to name things a certain way, forces you to do certain things. Now, if you're Rails, that's great. You're Rails, if I'm going to work in Rails, I'll shape things to what I'm doing. But if you're a third party, if you're a smaller library, you might want to think twice about how much you enforce about the naming and paths that other people have to abide by. The example that I have here is the SQL ORM. Now, I want to be clear, SQL is an awesome ORM. We love it, it's great. And we especially love the fact that they provide a plugin and extension architecture. Like, they have thought through the fact that people are going to want to plug into this. And they've provided a lot of functionality around it. There's a whole huge list of plugins if you go out to the project. This is the line that shows you how you can register a plugin with SQL to, put that extra sort of stuff in there. But there's a little bit of a rub to me about how this gets implemented. Because basically what this boils down to is a required that looks for SQL plugins, New Relic instrumentation. Now, maybe I'm just being a little pedantic about things, but when I look in the lib directory for my gem, okay, New Relic folder, that's where most of my code goes, that's great. Tasks, okay, that makes a lot of sense. New Relic RPM, gotta have that in SQL. Like, it's a little awkward that I'm being forced to put SQL at the top level of my structure to have things end up the way that they need to get picked up. So it would be a fairly simple thing to address by just letting us pass a class or module. Let us pass in the thing that we want to hook into you, rather than something that you evaluate to a path to go look it up for. Again, just a consideration depending on what sort of library you're writing and how broadly it's used. I also have a little bit of a thing. So in Ruby, there's a lot of very colorful naming for our gems, and sometimes we get made fun of. And I'm not actually gonna pick on that at all. But every once in a while, we also kind of go to the other end of the spectrum and name things a little generically. Like, here's my implementation of the active record pattern. I called it active record. Here's the data mapper pattern. Data mapper. I'm gonna write an HTTP client. I'm going to name it HTTP client. This isn't a huge thing, but then if somebody else wants to use any of those words in their infrastructure, like if you have multiple HTTP clients that you actually wire into, it gets a little ambiguous when one of the specific libraries that you support is named HTTP client. No, not the HTTP client. It's the HTTP client, HTTP client. Like, it's nice to keep in mind that you might want to go with something that's a little more specific. And I know it's hard to come up with good names at times, but it's probably worth your time. This also leads to a lot, so naming also leads to a lot of issues around how you qualify your code. So when I say qualify, that means how you specify the modules where things live. And there's a lot of dynamic things about how Ruby will look up to find code for you. And occasionally, depending on how you name things, that can come back to bite you. So here we have a mistake that I personally made. So we were adding a little bit of functionality. We wanted to have some consistency around how we spun background threads up within the New Relic agent, because we have a couple of them. And I thought, hey, I'll make my own thread class that kind of has our extra little bit of stuff that we want there. Everything's good. Well, not so much, because somewhere else out there in Gemland, somebody wanted to reopen the standard library thread class and do something to it. Their code, unfortunately, ended up getting executed in a context where we were looking up into New Relic agent, and guess what class they found instead of the standard library thread class? They found my class. So we ended up renaming it, which is a little unfortunate because it feels like it's the clean thing to do, but there's some peril if you are going to name things after the standard library. Now, I've had people make a little objection to my comments on this that, like, well, any gem out there could name something, a name that you're going to use, but I think it's mostly around the really commonly used things. Like, if you're shadowing the name of something that's in the standard library or maybe in Rails, you might run into cases where there could be some ambiguity or things that will get looked up in a way that you might not be expecting and that you might not be testing for because it relies on other pieces of the gem infrastructure being loaded that you're not really putting into your environment. Embarrassingly, we had a similar sort of thing happen with the New Relic itself. So there is a plugin gem, which this is responsible for communicating your own custom metrics to the New Relic platform, which is different than the New Relic RPM, the Ruby agent that's there. And in the plugin, they defined this logger class. Seems pretty reasonable. It's in, the new Relic module. But I bet you can all imagine what's probably going to happen next. In new Relic RPM, we had the agent logger. Now, I know the naming's a little odd, agent logger, but roll with me here. We learned from that. Unfortunately, we had this. We weren't using the plugin gem together with the agent because we hadn't tested that combination, and there wasn't a lot of functional reason for it. But you can guess exactly which class got found when this line of code executed. You put two New Relic things together, and it bombs. That's not a good experience. This could just as easily have been with somebody else's gem and some other thing of the naming. And it's annoying because the fix is 2 characters. I really think that if you're writing a gem, you want to be very cautious, very conservative about the ways that you lean on the module lookup rules. Because you can't always assume the context in which your code is going to execute. Unless you're way smarter than me, things will come out and bite you. And it's just a matter of 2 colons to make sure that you're talking to the class that you think that you're talking to. So that's names and paths. It's easy to get those mixed up, and it's definitely something that's hard to test for at times, so keep your eyes closely on it. Configuration is another part, especially if you write a larger gem that comes into play. Ruby's got a pretty good standard built-in mechanism. Now, all of the noise around YAML with the security vulnerabilities earlier in the year, I don't really feel like makes it invalid as a configuration file format. If you're slinging data across the wire in YAML, you're going to have problems. But config is kind of what it's there for. If you want a little more dynamic thing than just those sort of key value pairs, though, you can also mix this up with ERB a little bit. An example of how you would do that is we read in a YAML file. We can then use ERB to evaluate that. And what that lets us do when we load the YAML is people can embed some templating in there. So here, they can get that default awesome key that we handed in from that external environment, or they can run any Ruby code that they need to. It's potentially a little ugly for people to do that, though, if they need to do something really dynamic. And so there has been a resurgence of a new language for doing configuration in the Ruby space in the last couple of years that you might want to consider. And that language is Ruby. Prime case of this is Unicorn. You provided a config file. It's a Ruby file. It gets executed in the context of a config object that provides these methods. The nice thing about this is that all of the configuration can go together. Things that need to have code associated with it. An event handler can be defined in here alongside the other config that's there. Puma has similar support for this sort of RB file, which is really nice. And you can see on worker boot, so it has a forked mode where it'll send off other child processes. So we're doing, here's an example of how they would wire the database back up. There is a little downside to this sort of configuration file loading in Ruby, though, that you got to be aware of. And that's if you are writing for gems to be able to wire into that as well. This is very clean for the app to write that RB file that gets loaded up. But if some third party wants to glom onto that, you want to make sure that your interfaces are nice for it. So this is what we actually end up doing in the case of Puma from New Relic. And you don't have to read all the details, but it's kind of ugly for us to be able to interact with that from the code rather than from that config file. In particular, it relies on the CLI config, which is not actually always present depending on the way that you start Puma up. We're working with the Puma folks. We love Puma. It's awesome, and we want to make this a little better. But making sure that you provide a code-based way of facing your config as well as the file-based loading that people might commonly use is a really good idea if you're going to write a gem that has a lot of functionality to it. So that's configuration. The bigger your gem gets, the more likely that you are to want to let people get in there and do things that you might not be expecting in how you configure it. The last place that we'll go is documentation. So READMEs. Most people will not get past the README. So if you've got ways that you expect people to hook into your application, expect them to modify your gem, at least call out that that documentation exists from the README. Maybe you don't need to be like Sinatra, where you go to the README, and then there's the table of contents, and then there's still the table of contents, and then there's still the table of contents, and then all the stuff is in the README page. Yeah, that might be a little overboard, but make sure that the pertinent details and the fact that you've thought about how people should extend your gem shows up there early, or people are going to start looking at the code and digging in and monkey patching things that you don't expect. Sidekick is a great example of this. There's a wiki out there. It's got a lot of articles, and they're very specific, and you can see that it tells you about the internals, it tells you about middlewares, it tells you all of those different pieces that you can customize about it. It's very accessible, and it made it very easy for us to work on instrumenting it from New Relic. Don't bury the things in your documentation that people care about. And here I'll give a counterexample that we've just fixed. So our documentation used to look a lot like this, and it scrolls, and it scrolls. How do you know what class you're supposed to use? There's no real way for you to tell that as somebody external. We've thinned that down. Make the things that are important for people to get at, the things that show up when they first go to it. And then they can read the code if they need to get into more details and do something more complicated. Also, the version of your gem is part of your documentation. Consider using semantic versioning to make that clear when things appear so you don't have to worry about, was it 037 or 035 where we added that hook? Semantic versioning makes that a lot easier to remember. So that's docs. We've covered a lot of material here. We've talked about how to pass things through, how to event things, how middleware can help you, the life cycle of gems, names, config, docs. Hopefully you found something in here that'll help your gems get better, easier for people to work with, and save you and your clients pain. Thank you.